Our next speaker will be Don Stromley. Don is a technician and a construction superintendent in sales and engineering research with Advanced Composting Technologies. And today his talk title is Composting, Dead to Dirt in Days. So if you could give me a hand in welcoming Don.
Good afternoon. Can everybody hear me okay? Is that good? A little closer? Better? Okay. My name is Don Stromley, again with Advanced Composting Technologies. We are a North Carolina-based company that we've been in business for over 25 years now. I got the message that they wanted me to talk about composting, which is the topic that nobody wants to talk about, nobody wants to deal with. But if we do it right and we manage it right, we can put this process together and get you a good product and keep the biosecurities and process rolling. A little bit here just before we get going is we'll talk a little bit about advanced composting, where we've come from and how we came about. Some of the sciences, I'm not going to get deep into the sciences, but just the main elements that we can kind of focus on that some of you might look at in regards to focusing on making your compost a better product and a better process. Some of the different ones that we deal with over the years now through USDA-NRCS. Back when we first got started, we were looking at joining up with a partner where we could take our initial technology and work with some people in the North Carolina area with the forced aeration. One of the areas in composting is when the microbial activity starts going, they use up all the air. And that's one of the biggest things in a static pile composting is that you run out of air, the microbes drop down, the temperature drops down, and you start losing the process. So that was one of the things that we started with is air. How do we get air sustainable to those microbes on a consistent basis without air conditioning the pile and without leaving it out of balance with the other nutrients and the other elements that we want to deal with. So we've worked with the years over the NRCS with the cost share and EQIP, and now I believe we're adopted now in over 30 states in the cost share. And we work with APHIS in catastrophic cleanups. When we have hurricanes, they call us up. We have another company that has subject matter experts, and we go out and consult with hurricanes. We also deal with the high path avian influenza and work with APHIS and USDA to get that producer cleaned up, that production cleaned up and back into business. Like I said, we've been in business for a little over 25 years. We started out with the air, and I'll get a little bit more into our pre-processor that we've gotten into here in the last 10 years. But I just wanted to start with the basics of composting. You take your composting, whatever process that you want to do. I'll talk a lot about static pile because there's still a lot of static pile bins that are out there. The bottom line is with composting, we all want to be good stewards, and as we be good stewards, we want to be good stewards to our neighbors and to the air and to the soils and to the water tables. So some of the practices that have been done in the past as far as burying and burning have pretty much come out, as far as economical and ecologically taboo. We look at something that we can do to process your daily dead and get it basic and simple and easy and get you an end product that has a full pathogen kill, a humus type product that we can put back out into the soil and as a soil amendment and get those essential nutrients that we're taking from your dead back out into the, and complete the cycle. So if you give the microbial activity the proper environment, they're a lot like us. You give them shelter, you give them a good diet, you give them water, you give them air, and they'll do all the work. You just got to keep everything in balance. And that's where we start with the elements. There's a lot of elements that go into composting. The four basic ones that we start talking about is obviously you've got the nitrogen, the protein. That's your daily debt. In our case, we might be talking finishers, we might be talking sows, afterbirth, AB, whatever, you know, that you have coming out of those facilities. We'll take it all. The next part is that we want to establish a carbon to nitrogen ratio. And as we start the process, we're completely out of balance. We want to get an end product that's somewhere around 25 to 1 to 30 to 1. So what we have to do there then is we have to bring in a carbon product. When we go and talk to the people, the last thing anybody wants to do in the production facility is go out and spend money on the part of the production that doesn't generate any money. But if you do something with it, you can get a good product out of it. So a lot of times we'll say, what do you have readily available for a brown carbon? And we'll start dealing with that. That's where we start putting our ingredient together and our recipe together and start dialing in for our customers to optimize our temperatures and our process. So up in the Midwest here, I do a lot with corn stalks, bean stubble, straws, hays. You'll see in some of our pictures a lot of wood chips, sawdust. That's down in the North Carolinas. I've got guys using rice hulls or any combination of any of that. What we want to do is get a carbon that is not necessarily fine like your sawdust, but that is a good absorbent. And not necessarily coarse like mulch or wood chips, because that won't break down. But if we can get something in the middle, the key to the carbon is, and your carbon is your energy. So the key to the carbon is, that's going to be our absorbent. Once we open up that carcass, we've got all this fluid. We've got all this grease and body fats. And what we want to do is we want to absorb that, and we want to hold that, and we want to use that in our process. A lot of you have seen other processes where they go down, and some of the ones where you'll throw your daily dead on the ground and you put some straw over it, and next thing you know, you've got fluids and leachate running around. You've got flies, you've got vultures, you've got scavengers. You know, if you manage this right, all of that will be eliminated. So by what we do now is we've got our nitrogen and our carbon. If you think about our carbon as our paper towel or our sponge, once we open up that carcass, that's going to take the fluids that we need. In our process, we need between 45 and 50 to 55, somewhere around the 50 range of moisture and water level. We get too high, you've probably been around some where it's got some sweet smelling aromas to it, some ammonias. We usually get high in water, we get high in nitrogen. We need to balance that out. So then we add some carbon. But we don't want to get too dry. We don't want to get under 40, 45%, because then that doesn't allow the microbial activity to move about through the pores and with the water that's, and moisture that's created. So now we've got the nitrogen, we've got the carbon. We've got the water, now, and we've got the air. Now how can we put these all together and consistently keep a temperature and the process going? So that's where, again, some of the things that we've put into this is the whole diet. This is the whole process that we can put together. We can take the carbon, the nitrogen, the water, the air, we can mix this and let the microbes do all the work. All we got to do is manage it. And by a lot of times when I talk to a lot of the people that deal with this on your facilities, they tell me static bins, it's all about days. How many days? We'll turn that every 10, 20, 30 days. Whether they do or not, that's their plan. So the key that we're looking at here now is we can shorten the days if we can optimize the temperatures and the process. So now we've got everything in place. Now we just got to keep everything in balance. And for those that manage it by the days, I try to get them steered over to start looking at your temperatures. If you monitor your temperatures and you see that there's a temperature that falls down 10, 12, 15 degrees, chances are one of the main elements that we just talked about, carbon, nitrogen, water, oxygen, has been depleted and out of balance. We want to keep some balance, some oxygen in this pile So that's why we use some medium to coarse carbon sources. So we can build up air pockets and have some porosity and store some air. That's where we're going back to our technology and our innovation is we started working with forced air 25 years ago, and how do we keep that air supply, since that's the big element that gets depleted, how do we keep that in the process? And that's where we started working on airlines in the floor to pump a consistent amount of air into that pile so those microbes never run out of air. That was our first forced aeration technology that we came across. So again, just to review, if we build the right environment and we manage the right environment and we monitor the temperatures and we keep that process optimal, we can get a good product out of the end of this. This is dealing with a little bit of what we were telling you before as far as our forced air. We flooded this floor to show you the little chimneys of air that we've got coming up in our forced air system. So this is one of the first things we did to supplement the air into composting piles to help maintain that. By doing that, we don't have to turn this, but we can maintain the temperatures that the compost process needs to get that pathogen kill. With NRCS, they've told us that they'd like to see 5 days at 131 degrees. We like that. That's a partial pathogen kill. We've talked with the guys at APHIS and some of the other ones in the USDA. Our goal is to get 10 days at 140, 45, 50. We want to optimize that we can. We want to get a full pathogen kill, and including the animal diseases that might be in there, but also the weed seeds and stuff like that before we put that on the farm. So this is one of the aspects that we put into our systems. Then we started thinking about, now that we've got this, and it took us a long period of trial and error to get this figured out, but now what's the next thing? How can we make composting easier, simpler, basic, with less equipment and less workforce and everything? I'm going to go back to this for a little bit. This is just a chart here showing, and I haven't talked to you about what we call our preprocessor yet, but this is just a chart here that kind of shows how our systems can accelerate the whole process. By getting the temperatures that we need, by opening up that carcass and taking care of that stage one right up front within minutes. This is a little chart that shows this, in our case, sows, nursery finishers, static bin, and the loading charts. We can get a lot more capacity in our bins because we're pre-processing the animals right up front. This shows a static pile bin and sows and stage primary, secondary, and how many days it takes, 210 days, and estimated to process that sow, start to finish. If we put our forced air system in there, we can cut that down to 80 days. If we pre-process that animal, open up that carcass, grind that up, score those bones, and put it back onto air, we can shrink that whole time period down to 33 days. And the big thing that I run across, again, going back to the carbon, is everybody wants to skimp on carbon. But when I tell people don't skimp on the carbon, you want to put a base down, whether you're static pile composting or with our forced air composting. Put a good base down. That allows some air movement to come through. That allows some moisture to be caught and trapped, but it also allows your air to get into the corner. When we develop these bins and these windrows that we do for, in our case with our subject matter experts, we create windrows when we depopulate the high-path avian influenza. The key is building that core right, getting that core so that everything can optimize and we can get those temperatures and get that pile processed, moved on, and get that producer back into business. So by our systems, we can accelerate the whole process. And that's one of the things that, that we've come across as far as how can we better do this. So by doing that, here's just an example. And I've done some sizing for some other facilities around the Midwest. But here's a 4,000 sow farm with average mortality that we put into our sizing chart, 3,000 pounds, it tells me that for 210 days I need 36 bins. When I go and talk to a producer about having compost bins and tell him that according to your size, according to your production data and your mortality, you need 36 bins, he's going to have a few choice words from me because he can't manage 2 bins, much less 36. That same scenario with our forced air and our pre-processing, we can do in 5 bins because we speed it up. We speed the process up. We take care of stage 1 right up front. And I'll get a little bit more into this. This is our pre-processor. So this is an old TMR tub that we took and started with. We gutted it. We took the RPMs that you would normally have for grain and mixing, and we went and focused on torque. We put a heavy-duty planetary gear on the bottom and the motors on there. We did some toying with the knives. We've got aggressive knives on the outside for interference knives. You can put a sow in here and you can hear bones cracking. We'll run this for sows 25 to 30 minutes, and that's what comes out. Again, we got to have the right carbon, because once we open up that carcass, what we want to do is we want to collect that leachate. We want to collect those body greases and fats. That's our moisture level that we need to maintain. So we use that. We've changed a little bit now as we've gone along. We've been working with this for about 10 years now. We've done a little changes in the degree of the wall to create a pinch point. We've done a little adjustments on the push blade on the bottom to help swirl it around and get it up. But we can take our animal, whatever species you might have. We've got multiple sizes. We were in the poultry business. We're in the swine industry. We're in the food waste business. As far as also we're helping with some of these universities and resorts and some different facilities. We've got some guys that we're working with in Mexico with sugarcane, in North Carolina with tobacco. We've been approached to develop our technical system for human composting, and we've kind of put a pause on that. But that's something that's, I guess, being passed by a number of states. That's going to be the next thing down the road. We just have second thoughts about dabbling in that. But so we can take and put the carbon in there, take and put your daily mortality in there. For poultry, we'll run that pre-processor 15 to 20 minutes. For finishers, 20 minutes. For sows, 25 to 30 minutes. And this is what comes out. Then we take it over. We put that carbon down. I'm not worried about wasting carbon on the bottom, because as we take this out to our second stage, we're going to mix that in. And as we start mixing that in, we start recycling that material back in. So we still have good carbon, but we still have microbial activity that we can inoculate our next batch with. So this is one of the things that we've come up with. It's been a game changer for us. We can shrink it, like I showed you in those bin numbers. We can shrink the whole footprint. We can shrink the bins. The number of people it takes to operate this, is one guy in the afternoon. If you have a daily batch, maybe you don't have a full batch day. So that's one thing nice about this. You can put 500 pounds of carbon into that preprocessor and put your 500-pound sow in there, run it for about 2-3 minutes, get the carcass opened up, and wait until you have another 500-pounder tomorrow, and then run the full batch. When you've got, for the sows, we normally run about a 6,000-pound batch. 3,000 pounds of carbon, 3,000 pounds of mortality. Once we get going, we cut that carbon down to about 2,000 pounds of carbon, 3,000 pounds of mortality, and 1,000 pounds of our recycled material that's already been run through. So that's pretty much, as far as our process. The main things that I wanted to talk about with composting is management is key, and temperatures. If you can maintain those temperatures and keep that process going, you're going to get a product that's going to have a value-added product that you can put on your soil complexes later on. But this is something that we've dealt with, like I say, that we're learning from. We continue to learn from you. We've talked all day about innovative and technology, and we constantly are trying to figure out stay ahead, what's the next step. And with us, we've been asked to prove ourselves as far as the bones and the hides, but the big thing is, with the options that are left for composting, if you're static pile, or you're some of the other options, you know, there's inline vessels that are, you know, have limitations. There's still another option. There's incinerators that are dirty and very costly, but we can get this set up, and with NRCS, we have to stand behind our processes for 15 years. So that's why we haven't cut any corners. We take the bottom 30 inches of that tub now, and we've changed it to stainless steel. We just want these things to last. We've changed in the maintenance part of this. We've gotten it broken down to if you run a batch a day, the blades will probably need replacing maybe every year and a half, 2 years, a pump of grease every 2-3 months, and a change of oil once a year. The big thing with us is, and here's a batch of sows coming out of the preprocessor. We've taken care of stage 1. We don't have to wait 60 days for that first bin to get filled up and then get through the heat cycle. We can break that carcass opened up and get a processing and take it, put it on air. We've already taken care of stage 1. So that's our whole concept as far as how can we make this simpler and easier and shrink the footprint. But the other thing that I was going to get to as far as the other options, rendering trucks are getting fewer and fewer. But back about 5-6 years ago, when we started doing testing, if we ever have to depopulate some big sow farms for African swine fever, we've gone through the processes, we've gone and seen what we want to do, but the biosecurity has become so important in the swine industry. Rendering trucks are becoming fewer and fewer. Companies are becoming fewer and fewer. We're just afraid to bring any more trucks on. So that is one aspect of that, and I believe that we're going to see that, we've said this for years, we're going to see this in other species. So now we're seeing it in the poultry, we're going to see it in the dairy. Cattle, kind of a different game because you've got open lots and stuff like that, but biosecurity is going to find its way into all the species, all the industries. So it's just something more that we're aware of. We work with our customers, we work with the industries. How can we make this easier? One of the first jobs that we did down in Oklahoma, we showed them our data, and they said these numbers can't be right because they were too good. We showed them, we proved them, but we also went back and got a third party to go out to a poultry facility and a swine facility and do third-party testing. So now we have a third-party testing showing that our data is correct. We can do this. We can get the results by doing the process the way we were talking about it. Our big thing is, and I just preach as far as, you know, any compost that you do, management, management, management. And that's tough. With some of the bigger facilities, you don't have the consistent person to go out and do this day in and day out. Of course, nobody wants to do it. Whoever gets a short straw is going to go out and deal with compost. So we want to make it easy, we want to make it simple, but I tell people temperature. Temperature is your performance. That's the big key. If you manage it right, you get your temperatures, you'll get your performance. And we get a full pathogen kill. We have a product that we can use. So that's part of our whole system as far as composting. Like I say, you know, we're continuously trying to find new ways to make things better. And as we talked about, you know, in some of the speeches this morning, you know, the next few years is going to just speed up even faster for technology. Some of the different values that come out, we just had some tested here within the last couple of weeks, and there was, I think the last one I saw that came through yesterday was a swine facility that the test analyst, the lab test came back at about a 12, 15, 19. So there again, when we have this product that we can put back out in the field, now if you're a row crop producer as well, and you know the cost of fertilizer going up and input costs going up, now you've got something that maybe you've got a value that you can put back out. That carbon that you've got, those nutrients are essential nutrients that will go back into your soil, and those nutrients will slow release back into that soil. So we've completed that cycle. We've taken your dead, processed it, killed the pathogens, processed it down to a good humus product, got it back out in the soil. Now it's got a good value to it back in the soil. We've got a demonstration model that we have for our preprocessor. We had at the World Pork Expo, and we travel around to do experts. Bruce has had it out to Purdue, Arkansas, I think the next one. We work also with, up in the University of Maine, the Extension Office has a carcass management course that we've all gone through, so we're all on a list that if somebody needs to get deployed out to some of these, we can go out, sit down with the USDA people, put the formula together on what we need, how much room we need, and again, the big thing is how much carbon do we need. We get through our formulas, we go, because we may have a facility where it's not just the birds, it's the litter, it's the feed, everything's been contaminated. So we've got to take and put all that into consideration, and we have to process that and get that all so we have a good pathogen kill. And we look at people and say, all right, here's the results of all of our formula. I need 150 trucks of carbon. And they look at you like, how soon? And we go, tomorrow. This is part of our plan to be prepared for any of these animal diseases that might hit, is the process and the plan and the elements that you need to make your process go through. We also now have a little trailer that we put our airlines in so we can demonstrate that as well. But we go out and do field days, we go out and do demonstrations, we work with NRCS in some of the different states, but also with the USDA on these. That's the nuts and bolts on composting and advanced composting technologies. Any questions? So the material that comes out of the preprocessor, after you've filled your bin up, we leave it in that bin. So for poultry, once we get our bins filled up, we'll leave it on air for about 14, 15 days. Finishers about 18 days, and sows about 21 days. If it's pre-processed, we'll just leave it on air. Then we take that out and we put it into a second stage. And that second stage will be, after we've turned it, we were going to get some air, so it's going to come back up, but we start using that material right back in the recycle. And we leave that the same days as we have on air. So in sows, we'll leave that for 21 days. We'll take it off in second stage, leave it for 21 days. That helps it cure down. We'll use some of that, and after 21 days, we can move it over to our finish and dry down. We've gotten the process done, we've gotten the pathogen kill.
So I saw on the slide before this one, you had one of your temperature recorder on your portable unit there. Do you have similar ability with the on-farm units that aren't portable to be able to monitor that temperature on a regular basis?
Yeah, we were using data. Is it data logs, temp logs? What you're using in the trailer now? Yeah, we're using temp logs that we can put into, or you can put in the pile, download it, and you can put in there. Is that what you're looking?
Well, I'm specifically talking about something that doesn't require the person that's supposed to be managing that to do something. In other words, can you continually monitor that temperature?
Yeah.
And maybe even have that access remotely, so somebody sitting in an office can monitor the temperature.
That's what. Yeah, these data logs that we're using right now. You can download it, and then you can tell it if you want to do it Tuesday, Thursday, and Saturdays at 10 o'clock, and it'll put on your laptop or your phone what the temperatures are at that time.
So over the internet today, then one person can monitor 20 or 30 or 40 of these?
Yes. Yep.
Yeah, okay.
Composting requires, the best method for composting requires a constant supply of material and that it comes in regularly. There's some variation with sows, of course, but probably a big opportunity in Iowa and the Midwest is with finishing sites, which are all in, all out, and it's not a very consistent supply. Have you worked with anyone to try to solve that part of it? Because that's the application I'd be interested in is. is that. And then the second part for forced air, when you have a low level of material in January, it's not really ideal because you lose your fire. Have you ever considered trying to use barn air to run through your aerator system? So that's two questions.
Yeah, so the second part of that is, yeah, in the Midwest, see, we have different size preprocessors. So with a finisher, I would have like a 3,000 pound. So it'd be 1,500 pounds of carbon material, 1,500 pounds of your finishers. Now today, if you only have, that's one thing that's nice, rather than having to go in and layer 2 or 3 or 4 at a time, you can put 1,000 or 2,000 pounds of carbon inside that tub and put your, today you've got 250 pounders. Put 250 pounders in there, run it for about 5 minutes, get the process started, make sure you've got enough carbon to keep that so that the flies, don't, start building up. But you can build inside that. It's the same with, with the poultry industry where they have chicks at the beginning of the turn. It may take, for them in the broiler industry, it might take 2 weeks before you get a full batch. For you in the finisher, it might take you, I got guys that are doing the finishing and they're running 1 or 2 batches a week. But in the meantime, they're doing partials in that tub, getting the process started. And in a couple of days, we'll have 140 degrees in that tub. In the wintertime, we don't do the partials because we're afraid that might frost up and freeze up. But I have been out into Iowa here in some of the compost piles that we have on 0 ambient air days and have frost all over the truss dripping on me and everything, and I was registering 158 inside that pile. So,
as long as you're feeding it that way.
Yep.
But if you go for 10 days and you don't have any material, which is my hope.
Yeah. So with the forced aeration, we can start doing that, because what we'll do is we'll start in the back of the bin. We'll put the air on. We'll put the carbon layer down, and we'll start layering that material, putting that material in the back end. And with that on, the process is going, and it might take us 14 days in a finisher to fill that bin. But in the meantime, that process in the back is going and getting the temperatures built up, and the microbes are feasting. So that's the thing that the cold air, I understand, the cold air, what you're talking about, it's like for those who compost outside and don't have a roof system on there, when the rain comes down, it retards the whole process. Or if it stays out in the sunlight, it kills off some of the microbes. So a roof and a shelter help out. But in your case, what you're saying is the partialness like that, we can keep our process going and keep the temperatures going as we're filling those bins.
I don't want this to be a yabbit
Yeah.
conversation, because that's not intended to be that way.
Yeah.
It's really trying to figure out, is there an application I've got 5,000 finishing pigs, and I get placed in January, and in the first 3 weeks I lose 115 pounders, something like that. Mm-hmm. I mean, that's quite a little bit. Something like that. I just don't know that. Is your grinder of the material that it can stand that storage then, and that activity? I mean, I don't know if that degrades the material prematurely, the structure of your grinder prematurely or not.
Not really, no.
Not really?
Not that we put that stainless steel 30 inches around the bottom.
And the bin is just painted.
Yeah. So we don't leave it in there, very long, but until we get a full batch, we'll fill that up and do partial batches inside that. What part of the state are you? Right here? Okay. I can line you up with a guy over by Carroll who's got 9,000 spots that he has for finishers in Crawford, and no, he's got 25 in Crawford and 9 in Ida. And, he loves it. He doesn't have an issue with it. And he does his partials. He does so that he'll have about every third day he'll do a full batch. That's what nice thing about this is, if we do incur any spikes and everything like that, maybe you got to do another batch, maybe you got to do a second batch a day. Another trend that's coming that I see with some of the bigger guys that have multiple sites, they're putting a facility like this on a central location and bringing everything in. But the only thing bad about that is now we're back on the roads.
It looks like rendering to me.
Yep. Yep, you're back on the roads.